I'd like to say just a few words about paradoxes. My name is Bob Milnikel. I teach in the Department of Mathematics, and paradoxes are actually a great way to find your way into some mathematical topics, going back all the way to introducing the idea of motion and infinite sums and some basic ideas of calculus from Zeno's paradoxes of motion to some more 20th century applications in logic and philosophy from some really old paradoxes. But the one I want to talk about today is known as Berry's paradox. It was first written about by the early 20th century philosopher and mathematician Bertrand Russell, but he attributed it to the librarian at his college library, a man by the name of Berry. The idea here is that we're going to talk about describing numbers, not about the numbers themselves, but about their descriptions. So I can talk about the number of fingers on my right hand, 5. So that was a short description of the number 5. I could talk about the smallest odd prime number. It's a short description of the number 3. Of course, most phrases are not going to describe a number at all. You could talk about, you could say, it is a beautiful day outside. It's not a description of a number. Or the color of my shirt. Well, whatever that's describing, it's not really a number. Most phrases in the English language are not going to describe a number, but certainly some of them will. But if I talk about the smallest number which cannot be described in fewer than 20 words, I've just described a number. Because of all the possible phrases in English of 20 words or fewer, there are only so many. I don't know how many words there are in the English language, but it's on the order of hundreds of thousands. There are lots and lots of ways to put those couple 100,000 words together. Most of them are going to be gibberish. Most of the ones that aren't gibberish won't actually describe a number, but however many describe numbers, there are only finitely many that do. That means there are a lot of numbers, of the infinity of numbers out there, that we don't describe. Of the ones that we can't describe in 20 words or less, there has to be a smallest one. And yet I've just described it, the smallest number we can't describe in 20 words or fewer. So this is a paradox that really has no resolution, but the analysis of it, when you start to think about what it means to describe something, gets into some issues of philosophy. It gets into issues related to sort of what do we know and how can we know it. It gets into issues of language. What does it mean for a phrase to describe something else? But it can also get into issues of logic and mathematics. One of the most brilliant developments in mathematical logic that I think is really undervalued was a wholly new proof of one of the great results of mathematics in the 20th century, Gödel's incompleteness theorem. The theorem dates back to the early 20th century, but in the 1980s, a mathematician named George Boulos came up with an entirely new proof of the theorem based on this paradox of Berry's. Certainly not time to get into that in a 4-minute lecture, but it's a fun paradox and yet another way that paradoxes can build into mathematics.